For this lesson, we're going to be talking about using the distributive property, and we're actually going to kind of be working in reverse of distributing, called factoring, and we're going to be factoring some things. So the first thing I want to do is remind you guys how to find the GCF, or greatest common factor. To find the greatest common factor of two numbers, what you need to do is find the prime distribution of them, or prime factorization. So remember, you always try to take out the smallest prime number, 2, and 24 divided by 2 would give you 12. 12 divided by 2 would give you 6. 6 divided by 2 would give you 3. So you could say 24 is the same thing as 2 times 2 times 2 times 3, or you can also say that as 2 cubed, because there's 3 2's, times 3. Then also for 36, you can break that down, 2 and 18, 2 and 9, and then since you can't take out a 2, you go to your next smallest prime number, and 9 breaks down to 3 and 3. So 36 is 2 times 2 times 3 times 3, or 2 squared times 3 squared. And so that would be your prime factorization. And then remember, GCF, or greatest common factor, you look for which factors are biggest. Well, they each have a 2, and they each have 2 2's, you can see. And then they also each have 1 3. Now, even though this one has 3 2's, 36 only has 2, so the greatest common factor would be 2 squared times 3, or 2 squared is 4 times 3 would be 12. That's the biggest factor that is common to 24 and 36. Another way you may have seen this done sometimes is that once you get this prime factorization right here, you look for common numbers and you circle the one with the smallest exponent. I see 2 cubed, 2 squared. 2 squared is smaller. 3 squared and 3 to the first. 3 to the first is smaller. And notice that's exactly the same thing I got doing it the other way. Okay, so hopefully this is all just a review, things you've already done from junior high, finding common factors. And what we're going to do, we're going to use our distributive property to factor, and we're going to work backwards to express a polynomial. Remember, polynomial, more than one term, as the product of a monomial factor and a polynomial factor. So for example, we've got 1.6w squared plus 6w. And if you think of 1.6w squared as 1.6w times w plus 6 times w, we've got this common factor of w. W is being multiplied by each of those things. And if you can remember, multiplying something by two different things, that's kind of like distributing. So we work backwards and we write this as if we were going to distribute the w. So we'd have w times a quantity of 1.6w plus 6. And notice, if I'd multiply or distribute the w, you would end up right what we started with, 1.6w squared plus 6w. So we're not actually changing anything. We are just showing that we could rewrite it this way, and this is called factoring. Okay, and we always want to find the completely factored form. That just means we want to take out as much stuff as we can. But the main thing I want to see here, you can only take something out if it appears in each part. We had a w appear in each part, we multiplied each of them by w, and that's why I could take out this w. You can only take out things that are multiplied by each factor. So let's use the distributive property to factor each polynomial. First thing you need to do is find the greatest common factor, 27 and 18. And you could break these down into your factor trees. So 27 would break down to 3, 3, and 3. 18 would break down to 2, 3, and 3. This is just like what we did on the warm-up. Okay, and this is a 3 right here. So the greatest common factor for just the numbers would be, I have 2 3's in each of them. So it would be 3 times 3, or 9. So I know there's going to be a greatest common factor of 9. And then I got to look at my variables. I've got y squared and y. Well, obviously, the greatest common factor of y squared and y is going to be y, because y squared is y times y. And you can see these have a common y in them. So now I can see my GCF is going to be 9y. And you don't have to show all this work every time, but when you start out, you might want to do this just to make sure you are finding the right GCF. So I've got 9y. So I need to figure out, eventually, I want to factor out this 9y and see what's left inside the parentheses. And you can skip right to this step that I'm starring, but I'm going to show you an extra step that might make this make a little bit more sense. So I know each of these have a 9y in them. So now I have to think, 9y times what would give me 27y? Well, I know 9 times 3 would give me 27, and y times y would give me y squared. So 9y times 3y is 27y squared, plus 9y times what would give me 18y? Well, it would be 9y times 2. And then if you notice, we've got this common factor of 9y. Each thing's being multiplied by 9y, which means we can take those 9y's and we're just going to write it out in front and kind of think about, what would I have to distribute 9y to get 27y squared plus 18y? And then you can see I'm left with 3y plus 2 inside the parentheses when I factor out that 9y. And this is all factoring is. It's rewriting it, kind of going backwards to before you distribute it. You can think of it that way. And you can always check your answer. 9y times 3y, 27y squared. 9y times 2, 18y. Notice there's a plus sign here, plus sign there. It stays the same, just like when you distribute. So now looking at the second one, and some of these you're going to see a GCF really quickly. We've got 4a squared b, 8ab squared, 2ab. Obviously the GCF, it's going to have a 2 in it, because 2, 4, and 8, the GCF is 2. And then I look, each of them have at least one a, so a, and each of them have at least one b, so I'm going to include a b. Notice, it's just a to the first and b to the first, though, because even though this first term has a squared, the second term only has a to the first, and the third term only has a to the first. So I know I'm going to be factoring out this 2ab. And now I need to think about 2ab times what would give me negative 4a squared b? Well, 2 times what is negative 4? Negative 2. A times what is a squared? A. B times what is b? Times 1, so I don't need to put anything there. Minus, bring down your minus sign. 2ab times what is 8ab squared? Well, 2 times 4 would give me the 8. I've got the a I need, but I need b squared, and b times b would give me b squared. Plus, 2ab times what would give me 2ab? Hopefully this one's pretty easy, and you can see that 2ab times 1 would give me 2ab, and there's my answer. You get 2ab times the quantity of negative 2a minus 4b plus 1. And notice, if I were to actually go through and distribute this, I would get what I started with. So it's not, hopefully you can see where it's coming from. It is a little tricky, but once you do enough of these, you'll start to get the hang of it. So don't be too concerned if it seems a little confusing now. They will get easier the more you do.